So now we're going to look at factoring, and to factor a polynomial expression means to break it apart into a product of expressions that are smaller and simpler. Factoring means to break it apart into a product of expressions that are smaller and simpler, and really it's kind of like undoing the expanding that you practiced yesterday. So expanding, we'd multiply everything out. Factoring, we're kind of working backwards and rewriting the expression as a product of smaller and simpler pieces. One important strategy that we use when we're factoring is to factor out what we call a common factor. And a common factor is a number and or variable, so a number, a variable, or both, that goes into or divides evenly into every term of the polynomial. And so you can divide out by that common factor and kind of factor it out and rewrite it out in front. I'll show you what that looks like. So we want to find the number or variable or both that divides evenly into 4x squared and this negative 12x. And one helpful thing to remember is that 4x squared really is the same thing as 4 times x times x. So when we write it out that way, we can really clearly see that there's an x present in both of these terms, and both of these terms as well are divisible by the number 4. So the common factor that's present in both is the factor 4x, because we can divide both 4x squared and this negative 12x evenly by the 4x. So now we do that and just write what's left over in some parentheses. So if we were to take this 4x squared and divide it by 4x, the 4x and the 4x cancel out and all that's left is an x. And then if we look at the negative 12x, if we divide that out by 4x, 12 divided by 4, it gives us that 3, and really it's a negative 3. And then when we go ahead and divide by the x as well, x divided by x just cancel out to give us 1. So there's no x that remains here in the factored expression. So the factored expression is just 4x times x minus 3. And it's easy to check and see if we did the factoring right. We can always expand, either write it out or in our head, and make sure that when we expand the factored expression that we get back out the original expression. So 4x times x is 4x squared, and 4x times a negative 3 is a negative 12x. Let's look at one more and then you can try the other ones. Let's look here at number 2. So number 2, so the key here is to kind of scan through the expression and decide if we can divide every term by a number, by an x, or both. So looking here at the numbers, our coefficients, we have a 12, an 8, and a 32. And I can see here that all those numbers are divisible by 4. So I do know that I'm going to be able to factor out a 4. And then I can see here that my first term has an x squared, so I could divide that by an x or an x squared. The second term has an x, I could divide that by an x. But the 32 doesn't have an x at all. So I can't factor out an x because there isn't an x present in all three terms. So I think I might just be stuck with just factoring out the 4. So then we go through and just divide each term by 4 and then write the result inside those parentheses. So 12x divided by 4 is 3x squared. I'm sorry, 12x squared divided by 4 is 3x squared. Minus, and 8 divided by 4 gives us 2, so we get 2x. And 32 divided by 4 is 8. So we end up with a plus 8. We do always also want to kind of be on the lookout and see if we can factor what's in these parentheses any further. And we'll talk about trying to factor these trinomials later, kind of in the bottom section here of the notes. So go ahead and try numbers 3 and 4. Search for a common factor and carefully factor it out.